Okay, let's look at question 11. So question 11 is looking at your optimization. So it says, after traveling a distance of 20 kilometers from home, a person suddenly remembers that he did not close the tap in the garden. He decides to turn around immediately and return home to close the tap. Then it says the cost of water at the rate at which water flowing out of the tap is R1.60 per hour, and the cost of petrol is given as 1.2 plus x over 4,000 rands per kilometer, where x is the average speed in kilometers per hour. Calculate the average speed at which the person must travel home to keep the cost as low as possible. Okay, so obviously if you go too quickly, then your fuel price is going to be too high. If you go too slow, then you're going to pay more for the water. So we have to optimize the situation. So let's have a look here. They've told us cost of water is R1.60 per hour. They've told us the cost of petrol is 1.2 plus x over 4,000 rands per 1 kilometer. And then they've said that the average speed is measured in kilometers per hour. So we're going to need total cost, which means we need a unit of rands. Okay, so we're going to have to cancel out hours and kilometers somehow. Okay. So we can see the total cost is going to be cost of water plus cost of petrol. Okay, so now how do we figure out the cost of the petrol? Okay, well, we know that speed, okay, or average speed is given as distance over, the change in distance over the change in time, hence why it's kilometers per hour. Okay, but we need the time factor. Okay, so therefore the change in time, because we need to know how long it's going to take him to get home, is going to equal to the change in distance over the speed we're traveling at, which is measured in x. Okay, so the distance is going to be that 20 kilometers. Okay, so therefore we have this time factor of 20 over x. Okay, that will be multiplied by R1.60 per kilometer that we are traveling. So if we fill in this equation now, we have total cost equals to the cost of water, okay, which is the time we travel. So that's going to be 1.6 multiplied by 20 over x, plus the cost of water, which is then 1.2 plus x over 4,000. Okay, and now what do we need to do? Okay, well, we need to find this average speed, which will minimize the amount that we spend. Okay, so because we're doing minimization, we then have to take the derivative of this. So therefore, if we label this as cost of x and we take the derivative, let's see, wait, before I sort that out, before I do that, let's see if we can sort this out. 1.6 times 20, if you plug that into your calculator, you're going to get a value of 32 over x, plus, let's see if we can sort this out here. Okay, so I can put 1.2 times 4,000, and by doing that you get a value of 24. Okay, plus let's see, plus x over here. Okay, and then we can simplify, let's see, we've times that by 4,000, but then we can simplify it as well to get a value of 200. There we go. Okay, so why have I done that? Well, I've done that in order to keep the x on its own and not add it to the 24. Okay, the reason for doing that is because taking the derivative is easier. Okay, so now what you do is take the x up. So we're going to have cx equals to 32 x to the negative 1 plus 24. Okay, and then plus x times 1 over 200. Okay, that's just a constant. So now if we take the derivative of that, okay, we're then going to get the following. So we're going to take this 1 multiplied by the 32 and then minus 1, so that's minus 32 x to the negative 2. Derivative of a constant is just 0. And then the derivative of this we have to the power of 1, so 1 times this constant minus 1 is just going to give us plus 1 over 200. Okay, so that's what we end up with. And we've got to find where this is equal to 0 in order to minimize it. Okay, so after sorting it out, we end up with minus 32 over x squared plus 1 over 200. Okay, so we can take the minus 32 across. So let's just do it up here. So we end up with 1 over 200 equals to 32 over x squared. So if we just sort all of this out, let's see, I'm going to take that across and take this whole thing at the bottom. So let's just go up to top. So then what are we going to have? We're going to have x squared equals to 32 over 1 over 200. Okay, and if we multiply that out, we get x squared equals to 6,400. Okay, now we can just solve for x. Okay, and if we do that and we solve for x, all you have to do is square root it. You're going to get x equal to 80 kilometers per hour. Okay, and that's how we keep our cost to a minimum. Alright, so not too difficult, just to play around with the wording there in order to get our equation that we needed to then find the derivative of. Okay, that's how we do this question. Okay, if you're finding the content helpful, then please leave a thumbs up on the video. It does help me out quite a lot. If you are enjoying the content as well, then please consider subscribing to the channel. If you have any questions regarding this question, then please leave it down in the comment section below. I'll get back to it as soon as I can. And remember, it's never too late to have an OIC moment.